Hello. I realized with the last video that I didn't say anything about looking for outliers in the data, so that's maybe something that I should show you here first. So I've read in the data again. Now, how would we identify outliers in our data? Well, one simple way to do it is just to plot weights versus lengths. So you do that using the plot function. The x will be data $ weight, so that's the x values, and the y values, again we'll use the $ to pull out the length column, and we press Control Enter there. And I'll just expand the plot here to show you our data. Now, if you can see here, we've got a big bunch of points, data points over here, and then there's one value that's got very small length, an unexpectedly small length, and then there's another value that's got an unexpectedly large weight. Certainly not a realistic weight to have in this data set, because these are just seedling weights. It couldn't possibly be so heavy. So we need to find these outliers and correct for them. How do we find that? Well, I suppose the data weight, this guy, suppose we copy this. So this is just the vector of weights. If I press Control Enter, you'll see them all here. Now I can do a test on that one. Tests that is greater than 100. And if I do Control Enter there, you'll see all these falses coming up. But this test we can use to pull out. So if I copy this bit again and paste it, and now I use the square brackets to index. So if I put square brackets around that, what it'll actually do is anytime that this evaluates to true, it'll pull out that particular row. So I need to put a comma there. So the square brackets index, and before the comma is rows, after the comma is columns. So I'm pulling out the rows which satisfy this condition, where there's a true. So most of them will be false, but so this should pull out a single row. Oh, sorry. Yeah, it should pull out a single row of my data. I made a mistake there. Okay, so we now zoomed in on this data point over here. We found the data point which has an inordinately large weight, an extremely large weight, unexpectedly large. Now, if you see the rest of the values, they're around 2025, and this is 244. So it's possible that when this was being recorded, somebody made an error here and forgot to put in a decimal place. So if I want to correct that, I could either make it missing, but here I'm going to guess that it was an issue. So an issue with a decimal place. So what I'm doing here, I'm now zooming in to this object here, and I'm zooming into this particular column here. So I'm saying, give me the row which has a weight greater than 100, that's a single row, and give me the column which is called weight dg. So if I press Control Enter here, I'll get the number of 244. And I'm supposing that this is wrong. I'm going to overwrite it using the backwards arrow sign, the assignment sign. So this is a backwards arrow. It's just a less than and then a dash next to each other. And I'm going to assume that it should have been 24.4. If I do that, Control Enter, what it'll do is it'll overwrite this value 244 with 24.4. So I'm just correcting it here manually. So if I go back up to my plot and do it again, you'll see now that the plot has changed. So that outlying point is gone. It's been shoved over here somewhere in the middle there, which is where we would expect it to have been. There's still a problem here though. We have another data point down here. Now we have to again figure out what is that data point. So we'll go back now, do the same thing. So we start data, and we use that sign. Now instead, we'll say length. And now the length is less than 100 here. So less than 100. Control Enter. Again, we'll get all these trues and falses. That's not very interesting. But if I subset using that rule, and again, so I pull out the row for which the length is less than 100. We see again, it's in group D again. So I think both times we're dealing with group D. So that's a student group that were not very careful with how they handled the Vada plants. So here, group D, Vada, the weight here is 21 and the length is 43. Now what should that have been? Probably should have been 430. Now that's a bit of a guess. You could look at the other values for Vada. What are the plausible values for Vada? But I'm just going to say that they forgot a 0 here. So it's more likely that that should have been 430. Now this is a bit of a guess on my part. We're not quite sure here, but it seems a plausible guess. You could also make it missing if you weren't willing, but oftentimes you'll be able to look back maybe at a paper trail and be able to find, oh yeah, that was just a typing error. So if I now pull out the length, we have 43, and again overwrite that with 430 and make one more plot, and now we see very nicely the weight versus the length in the expected relationship. So that's a couple of hints on how to find the outliers in this data set and correct them. And this has to be done actually before you proceed with the analysis. Otherwise, your analysis won't be entirely correct.